division. Whole numbers and decimals, fractions later on. So really, I mean, it's a longer chapter, division, estimating, dividing. Notice that the numbers have gotten bigger. We got 2-digit divisors. Last year when you guys did your division, you went up to like teens. I think maybe we did some smaller 2-digit, but and we only spent a day on it. But here we are in 3-3, and this is where we ended in 5th grade. Our division work more or less here. So from this point on, big focus will be on decimals. Powers of 10 return to us here. I'll show you how that works. Dividing decimals and whole numbers. How does that work? Where does the decimal go? You've done it a bit because you divided with money last year, so you had to place your decimals. Roland, just turn around. Face me. There you go. You'll see this is more powers of 10. We're going to explore them. We looked at them with multiplying. We looked at it with scientific notation. We looked at it with exponents. We moved the decimal to the right. We made numbers larger. We did all this stuff. So we're going to do it all again, but we're going to look at it as division. We're going to look at it as this type. These are powers of 10 too. Did you know that? 1/10, 100th, 1,000th. Those are powers of 10, just like 10, 100, 1,000. More estimating, decimal divisors. This is where you're going to have to learn how to move decimals. You can never have a decimal in your divisor. Zeros are going to pop up here. Then we start, this would be better introduced in chapter 4, but here it is. Expressions, more stuff here. These are things that are going to go on forever and ever and ever, but at some point or another we have to cut it off. We have to just say we're going to round it to a point and be done with it. So this will pretty much give you everything on division. If you felt it went good for you last year, and as far as I can think, looking at the 5U, it went good enough that you understand generally how division works. But we are going to take it up a notch. I wouldn't say it's going to be earth-shattering stuff you're going to learn. I wouldn't really describe it that way. But you are going to learn some more concepts of division, take it a step further, add another wrinkle to what you already know to be true about it. All right, so today that is not what we're doing. Today we're doing short division. Short division's somewhat divisive. I will show you how it works. I do not force you to use it. Some people like it and will utilize it. Some don't. It's kind of split on how you feel about it. I don't really show it to 5th grade much, but so number 1 on page 89. That's where I am. We got 81,000 divided by 993. If I wrote this out, in the end, you'll see some in this form. Not today, but soon enough. In your homework, though, you'll see some this way. I guess they got a couple. They don't have, now I see them. 5 through 8, 17 through 20, right? They'll shift the form on you. Regardless of, this is the way you're going to want to solve them, right? I mean, if you're going to solve division problems, the first thing you should probably think of is, I probably need a division bar. Yes? You don't agree with that? Yes, because like literally nobody was looking at me. And I was like, man. Okay, but if you see it in this form, and again, you will, then you just need to, again, get it in this form, like this, right? Easy enough for now? Great. So from here, if we solve it, I'm going to solve it with long division first, because this is how most of us solve this type of problem. Then I'll show you how the short division form works. So 3 goes into 8 2 times. 2 times 3 is 6. Subtract, and I'm talking to you like you know what I'm doing here with division. If I'm confusing, then I can slow it down a bit. 8 minus 6 is 2. Drop the 1. Now I'm in the thousands column here. 3 goes into 21 7 times. Multiply. 7 times 3 is 21. Subtract. 21 minus 21 is 0. Next up, drop the 9. Repeat the process. 3 goes into 9 3 times. I'm being very careful of my place values here, making sure I get everything lined up right. That'll help me that I know when I'm done or terminating or making sure I don't miss a number or something like that. So 3 times 3 is 9. 9 minus 9 is 0. Drop another 9. 3 goes into 9. 3 times 9 is 9. 9 minus 9 is 0. Drop a 3. 3 goes into 3 one time. 1 times 3 is 3. 3 minus 3 is 0. I have no remainder. Look at that. I gotta like squeeze it around to just get it on the camera there around the recording. I wish I could get rid of those messages. Like, do I really need them here all the time? I don't. I really don't. But there it is. If you came up with 27,331, anybody? 4 and a half, 5. We all got it? Oh, that's great. If you got it, hey, I love what you did. I'm going to give you a smiley face. I'm going to draw a square for you too, because I think it's great. That's good. I love how you did it. So that's ultimately what this is all going to be about here. It's about getting the right answer. Whatever you feel comfortable, how your division method that you like to use, if you're hitting it, and you do you. But what am I saying here? I'm trying to teach you something, or at least give you another option here. Short division, not long division. This is long division, and we would probably all at least at the minimum agree that it is kind of long. For me, it took half a page of paper. How long did it take you?
It only took like...
Okay, Ella she kind of quartered up here, and so a quarter of the page for Ella. So some maybe more than others. Lauren, okay, it's very good there, Lauren. But if I'm going to do the same problem, but I'm going to show you how I can do it with what's called short division. Okay, requires a little bit of mental math, but significantly less writing to solve. So that's the trade-off. You're going to have to do a little mental math, especially subtraction on your own in your head. But if you can do that, you don't have to endlessly write all these subtraction problems out. Right? That's 5 different subtraction problems. Can I do 8 minus 6 in my head? Possibly. Can I do 9 minus 9 in my head? Perhaps. I mean, you are in 6th grade, right? Right? So I repeat the same process. 3 goes into 8 2 times, right? And 2 times 3 is 6. Yes? I know that. 8 minus 6 is what? 2. So instead of dropping all that there, because the next thing I do is I'd have a 2, drop the 1. But I'm just going to put the 2 up here, because notice how with the 2 up there, I got 21 or 21, right? Right? I did 8 minus 6 in my head, it's 2. Instead of dropping the 1, I just raised the 2. Right? So now I continue on. 3 goes into 21, how many times? 7. 7 times 3 is 21. What's 21 minus 21? 0. So if you want, some people like it, you can put a 0 here. If you're like, what's the point? Then don't. But if you want to put a 0 here, cool. Doesn't change anything. And I could just continue on. 3 goes into 9, 3 times. 3 times 9 is 9. 9 minus 9 is 0. And if you want to write 0, write it. If you're like, I don't, then 3. 3, 9, 9. 9 minus 9 is 0. Again, I can put a 0 or not. 3 goes into 3, 1. Boom. There it was, solved using short division. Basically, anything that I would carry over when I do my subtracts here, it's just right here. There's the 2, the 0, the 0, the 0, the 0, the 0, the 0. Right? So you see kind of how I did that there? Give it a shot for a couple. I'm not saying you have to do any of your homework this way. I'm not. You don't. I'll walk through it here a couple more times, but just give it at least a moment here. It doesn't matter. Even if you get it wrong, it really doesn't matter. You need help, Michaela?
I'm literally going to crash.
Okay. All right. So short division. I'll walk through it and see what you think. Listen, sponge up. Anybody give it a shot and
Yeah,
Yeah,
I
oh,
did.
okay.
I'm currently working on it.
okay, I'll give you a. So same exact process. Nothing really changes with the division here. It's just I'm doing some things in my head. So this short division technique, it really only works for single digit divisors. So we're going to be shifting over very soon to this type of stuff. Short division is not going to work for that type of scenario. So it has kind of a limited spectrum in what it can do for us. It really only works with single digit numbers. Because again, we're not going to be able to do this 2-digit, 3-digit numbers all in our head. That's just too much. So really single digit divisors. So that's what its usage is for. And again, you can notice the problems are structured in the sense that everything is a single digit divisor. 1 day of single digit divisors. 6 goes into 8 one time. 1 times 6 is 6. 8 minus 6 is 2. So I put my little 2 up there. 6 goes to 24 4 times. 4 times 6 is 24. 24 minus 24 is 0. How do I do it here? You could put the 0 if you want. 6 goes into 1 0 times. So then 0 times 6, 1 minus 0 is 1. And again, if you put the 0, then maybe you just put the 1 right here, because you got 6 times 0 is 0, 1 minus 0 is 1, 1, drop the 7, 17, 6 goes into 17 2 times, 6 times 12, or 6, 2 times 6 is 12, 17 minus 12 is 5, 17 minus 12. And then 6 goes into 54 9 times. We'll have endless opportunities to check our answers throughout this chapter. We will, just for one here, but to check any, you will have endless opportunities throughout the check. But to check anything, you take your quotient, multiply it times the divisor, it should give you the dividend. Or your answer times your little number should equal your big number. So 4, carry the 5, 12 and 5 is 17, 6, 0 and 1, 24, 6 and 2. Right back to where I started this thing. You might also notice, if you're looking real carefully, 5, 1, 2, 5, 1, 2. The same numbers in my multiplying are sitting over here in my division bar. Is it a coincidence? Probably not. But, yeah, I mean, we'll talk about, would I check them on your homework? Doubtful. No. Guaranteed no. Quiz, depending on the mood I felt at the moment. Official position, yeah, definitely check them on your quiz, definitely. Test, I'd probably be more motivated, just because I would be like, man, I hate those test corrections. I'd rather just not do those. I would not be a good test correction student back in the. But now I'm a teacher, different. Student, I know how it would. I would have did my best to not have test corrections. Okay, try number 3 and 4. I'll pull a couple sticks. If you can kind of verbally walk me through it.
Do we have to do it in short division?
Give it a shot. 2 more. After this, I'll let you be free. We'll do a few more, and you can do whatever method you want, but let's see if we can try to walk through as a class 2 short division problems.
I did not understand.
This? You were all cracking toward the middle. You see me? Stop. Don't talk to me. Well, spring.
Okay, but like,
Yeah, we found a couple.
okay, but so like for 3, would I, so I got a 0 for each division, would I put like, because there was a 1, so for a 0 on number 3, would I put the 1 left over on the Maddie, or should I just leave it like that? And do the other? You can do whatever you want. Rusty, like, what's the point of going through your meeting? Go with whatever feels spiritual. Go with the flow.
All right. If you're woefully uncomfortable about the short division and have just mailed it in, or you're like, this ain't for me, then I'll put you back in the cup, I suppose. But my hope is at least 2 of you feel confident enough that you can just. Well, yeah, that's all. That's all I ask. It's fair. Yeah, we'll try 2 more together again, and then we'll try some, and you can use whatever you think. But the benefits are doing all this and all the paper in space versus this, versus that. You know, I could churn out a whole bunch of these types of problems on one page. Definitely wouldn't need a second sheet of paper to do my homework tonight, that's for sure. If I'm going this route, I need to get some paper out tonight to do the homework. If I'm going this route, I could probably do it all right in the book tonight. So that'll be your first choice. You want to get your paper out tonight, or you want to do it in your book? That shouldn't really be a selling point, though. But what the true selling point should be is, can you get it correct? What's comfortable for you? What are you more comfortable using? So I agree this took some getting used to, even back in the day. It took me a little getting used to, but now I'm used to it, and now I'm like, well,
It took T-Rex
now it's hard.
It took T-Rex a while to figure that stuff out.
Well, that's probably a bad analogy for us, Roland, because we ultimately know how it ended up for them in the end. So
Yeah.
ignore Roland's advice. It's just awful advice. You do not want to be a T-Rex.
Velociraptor learned it quicker than T-Rex.
Number 3, Noah, what do you think?
So 5 doesn't go into 4, so you put a 0.
Or whatever, okay.
And then 5 goes into 9 one time. So then you put
Well, we still never got it into 4, though. So the question would be, how many times would it go into 49?
Oh.
9 times.
9 times, right. Want to keep going with
Yeah,
this?
Badger 9 times.
Okay, he's not deterred by that. All right.
And then 9 times 5 is 45. 49 minus 45 would be 4.
Right.
Tiny 4 and run to 0. Then 5 goes into 48 times. 40 minus 40 is 0. And then and then 5 goes into 1 0 times, so it's a big fat 0.
Yep.
And then 0 times 5,
Yep.
yeah, it's 0. And then you go 5 into 35, and that's
No, because we had 1 minus 0 is 1, so then we got to carry the 1.
so 13. So 5 goes into 13 2 times.
2 times?
2 times 5 is 10. 13 minus 10 is 3. And then 5 goes into 35 times.
Right. Nice
I got that
job
right.
persevering.
Oh Lord, I had a phone call that someone.
The way I would personally write this, for what it's worth, and there's the 5, the 45, the 4, I'd write that. At this point, I don't write the 0, and then I would put you at that 0, but I'm not even writing the 1, because ultimately 5 goes into 13 2 times, and then, yeah, I would write that 3 there. So, because I'm ending up in 5 into 13 at some point here. You can write these zeros. To me, it just gets a little more cluttered with numbers I don't really need up here. So the only real numbers I needed was the 4 and the 3. Because this was a 0, 1, I could see that, and then carrying the 1 here, well, I could just, why write another 1 when I just got a 1 right there, like this? See how I did that the first time and then this time? So if I was honestly doing, this is how it would look for me. At the end here, I don't mess around with zeros and these numbers that I gotta carry over because it's just already there. So that's just me. No right or wrong answer here. Number 4, Stella.
So you can't do 7 into 3, so then you put, that whatever above it, and then 7 into, you can do 4 7s and 31, and then 31 minus 28 is 3, and then you can do 5 7s and 35, and and then 1 7 and 1, no, yeah, 1, and then you can't do 7 and 1, so that's a 0, and then you can do 2 7s and 14.
Right, that's how mine would look. I only had one number I wrote that time, so it's just a bunch of zeros and numbers that I'm carrying over from one spot to the next here. Or a 1. I mean, yeah, both of you did well explaining that. All right, I'll give you 3 more, so you 3 have your opportunity. Remainders. 13. I suppose you can give it a shot on your own real quick. You're going to have a remainder this time.
Oh, great, I hate remainder.
You could still use short division with a remainder. When there's nothing left, if you got, 3 minus, 3 is 1 and I got 2 left over, obviously there's nowhere else to bring the 2 to, it's your remainder. You have a remainder of 2. If there's nothing to carry over, nothing to drop down, and you still have a non-zero number left, that's your remainder. See if you can represent an answer with a remainder this time.
What's 30?
Wait, just 13.
Well, there's probably gonna be 2 others.
Better. Stronger, better. That don't kill me. Did you make me stronger? Never. I'm just right now. I can't wait much longer.
Addition.
I need you to hurry up now.
Earlier you guys appeared because you're
I need you to hurry up.
I'm done.
You gotta have way much longer.
Wait, did we just have to do 13? Oh, no, he's gonna give us 2.
Okay. So with the remainder, 4 doesn't go into 1. Nope. 4 goes into 13 3 times. With the remainder. 3 times 4 is 12. 13 minus 12 is 1. 4 goes into 17 4 times. 4 times 4 is 16. 17 minus 16 is 1. 4 goes into 19 4 times. 4 times 4 is 16. 19 minus 16 is 3. 4 goes into 37 9 times. 9 times 4, 36. 37 minus 36, 1. 4 goes into 13 3 times. 4 times 3 is 12. 13 minus 12 is 1. I don't have any digits left. Remainder of 1. Because 3 times 4 is 12. 13 minus 12 is 1. I don't have any digits left. If I checked it, 12, 36, 37, 16, 19, 16, 17, 12, 13, 137, 972, 137, 973. That's not the same, is it? Why is that? Oh, the remainder. Need to add the remainder on. 137, 970, 973. There we go. That's where I wanted to be. So, right, the remainder, basically, if you check it, you still do your multiply, but your remainder is just added on to the end. Add on. Small little add on. So, that's how it would be. Yep, you can use short division. You can use your long division. All right, here we go. Write the divisor.
No.
21 through 24.
No.
Okay.
Ew.
How many of those do you have to do? Well, single digit number. Let's give you 2 of these. If you can use the short division, or at least I'll write it out that way, that's great. What did we divide by? You divided by 5 and 7 so far. So how about 14? Then you can divide by 9. 836,138. And number 18, money. You should rewrite it.
Shouldn't we have 3 because there's 3 of us left?
Well, we'll look at the rate the divisor part then.
The last person.
I'm literally gonna crash out.
Huh?
I said I'm literally going to crash out.
Okay, we'll come see.
Yeah.
Now, 2 more. May or may not have reminders. First one, honey. Honey's always represented in 2 decimal places.
Hey, yo.
This is not going to solve my math problem.
Hey, yo.
That song. That's a great one. I love that song. I love the penny one.
3 times 0.
Yes. Oh, the penny bear. The construction one.
Yes.
I don't know, but late time. We can do it. Late time.
That's 200.
Can you please now? Shut up. Shut up. I'm trying. Oh, please shut down.
Shut up. Phoebe, us.
200,000.
Ben, what are those?
Oh my god. Please shut up.
200,000 in there. Okay. 200,000.
I'm not ready to singing.
Okay, 14. George is not here to help us. Lauren.
Alright. So, we cannot do. Okay. We cannot do 8 into 9. So, 83, 9. And then we put the 2 left over to the 6.
9 times 9 is 81. 83 minus 81 is 2.
And then 2 to the 6, 26, and then the 2 there. And then that, you also have to do 18, but now it's 21. So then there's like.
26 minus 18 is what? 26 minus 18 is
26 minus 18. And then what? 8? Oh,
8.
8. And then, so 8, oh, I did it wrong. 81
and then that's perfect because now we have a clean 9,
Yep.
and then 0, don't put that, but then 0 can't go into that, and then 9 can't go into 3.
Nope.
And then
9 times 9 is 81. 80 minus 81 is 0. 9 goes into 3 0 times.
Yeah.
0 times 9 is 0. 3 minus 0 is...
3 minus 0 is 3, and then put the 3 to the 8,
Yep.
and then that is 20, and then that, the 27 from last time, or that 4,
4.
and then 38 minus 36 is 2.
There we go. That's our remainder because I have no values left to drop down to that 2. That's just all that's left there. So. Yeah, good. Great. Nice job adjusting at the end there, Lauren, to all that. That was good. 18. So first thing you're going to want to do is rewrite in this form here. Fortunately, this one should be a non-remainder. This is an Ella situation for us here.
I did long division.
Okay. You could rattle it off. I'm writing short division, but you rattle. I know what I'll know what I need to hear. Okay. Let's do it.
4 goes into 6 one time, so that's 6 minus 4, then equals 2. Put the 4 down, 24. And then 4 goes into 24 6 times. 24 minus 24 is 0. And 4 is that. Then 4 goes into 4 once. Then there's a 0. Then add the 6, and then that goes into it once. 6 minus 4 is 2. Add the 8. That's 28. And 4 goes into 28 cents.
And final answer.
$161.17.
Right. Perfect. Yep, she did it all. She did it long division. She got it right. I just narrated her short division parts up, but she step by step did it. And again, I like it. She was highly accurate. She got the right answer. That is great. All right, last part. I must use this paper. 21. So, what you're asked to do this time is think like fact families again here. I will tell you that all these divisors are single digit numbers, right? Single digit, single digit, single digit, single digit. So it's not forever. It says you can use divisibility rules to help us. Well, that's awesome. We haven't covered them at all this year. That's somewhere in chapter 4, I think we do the rules of divisibility. Where is it here? Is it chapter 5, 6, somewhere? I don't know. 5? I must know. Where are they? 5. Where's my rules of divisibility? Chapter 6. Got it. There it is. There they are. The rules of divisibility. Remember them last year? No. Well, we covered them. The only difference is this year you're going to learn 8. Last year you didn't get 8. 8's too complex for 5th grade. So, there they are. So, but anyway, sorry, you got to flip to chapter 6 if you want to use it. Sorry. In all serious though, how can this help you? What you know is you're going to have a single digit answer somewhere between 1 and 9 as your answer, okay? You can probably eliminate 1 real fast because anything times 1 is itself, right? So most likely your answer is going to be between 2 and 9. All right? Wouldn't be much of a problem if the answer is 1. So the question is, what is it? How do you? You could set up a division bar, but it's going to be a single digit answer. The big key here that could help you is trying to look at these two numbers, because the first thing I'm going to do when I'm multiplying is going to be in the ones column, right? If I multiply by 4, because then as I keep going here, I'm going to have a 0 and so on and so forth here. But in my ones column, I'm going to have a 4. This is a 2, right? 1 times what is going to give me something that ends in 2. 2. The only thing that really makes sense is 2. And if I went through all this, I could use reasonable estimation, 3,000 into 6,000 2 times, right?
I just use reasonable estimation on things.
Right. 22. I'm ending in a 6. I got a number that ends in 8. What do you think the magic number could be? 3. 6 times 3 is 18, right? Because I got to have something that ends in 8. 6 times what gives me something that ends in 8? I mean, 1's out, that would be a 6. 2's out, that would be a 2. 3, ding, 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 18. 4 would end in a 4. 30 would end in a 0, right? You see how this works here? When you have a remainder, all you need to do is subtract it first, because remember we just subtract it off here, right? Subtract it off because we add it to the final answer then there. So for that one here, remainder 3, if I subtract 3, 6, what goes into 4? And again, you can see 7,000, almost like 70,000. What's minus 3, 6? What's 6 times 9? What? Or 4 minus 3 is what? 9 times what gives me something that ends in 1? Subtract the 3 from here. My bad. 67,401. 7,489. 9 times what gives me something that ends in 1? 9. And that makes sense. 963, right? So Roland, 24. Subtract 7. I got 20. I got a 5 something and a 0. What do I need here? A 5, a something. 7 minus 7 is a 0.
Wouldn't you need another 8?
An 8, 40. That seems to make sense. 8 times 8,000, 64,000. Yeah, use rounding. Cool. Got it?
Actually, kind of more like front end estimation, except I front end estimate 1.
If you're a journal person, page 22, 1 through 28. It shouldn't take ridiculously long. We're saving that for later lessons.
Okay, but let me go out.
Page 22, 1 through 20.
38.
38.
It's not gonna be too long.
12 seconds away.
I put a script on the lip and
38, that's still 6 more seconds. 4, 3, 2, 1.